Okay, so the last session for this course is talking about how do we apply association rules in order to extract pattern or rules from our data. So normally this is used for market basket analysis. For instance, given the set of transaction, we want to find rules that will predict the occurrence of an item based on the occurrence of other items. So we look at the occurrence of one item and then we see how to predict this item based on the occurrence of the other item. So for instance, this is your transaction in a supermarket. So we have many transactions here. So that's why they call it market basket analysis. So based on this transaction, we can derive rules to specify the association between item set that we have in our database. So for example, we have, okay, this is your X and this is your Y. So if you buy diaper, you will normally buy beer also. Okay. We can also say if you buy milk and bread, you will also buy egg and Coke. Okay? And then beer, bread, you also will buy milk. So this is important because this is how they determine the bundle promotion. So they bundle things that are not popular so that they can sell that product, or they can use this one to rearrange the supermarket. So diaper and beer placed near to each other. Okay, like milk and bread will always near to eggs and Coke. So easier for the client or the customer to buy the product. Okay. So one thing that we need to know here is that the arrow here does not tell you the causality. Okay, so the occurrence of milk is not because of the occurrence of beer and bread, but we say they are co-occurrence together. They occur at the same time. Okay, so when we look at the rules, for example, like this, we always count the number of times they exist in the transaction. So based on the counting, we will consider which one has high frequent occurrence together. So for example, like this, we define the item set as a collection of one or more item. So this is the item set. We can also specify the number of item set. So if we say K item set means K number of item that you have in your collection. Okay, so for example, if I say 2 item set, so that means in your collection you only have two item set. Okay, and we have some benchmarking. For example, the support count here, they look at the frequency of occurrence of an item set. So for example, like this, we have 3 item set. So if we compare with the transaction that we have here, we are looking at the number of times these 3 exist together in the transaction. So in this example, we have 2, so which is milk, bread, milk, diaper, bread, milk, diaper, and so only 2, one transaction number 4 and transaction number 5. Okay. we also have this support. So the support count is different from the support. Support is the fraction of transaction that contain an item set. So in this example, if we use the support here, basically we have 2 out of 5 transaction. So this will tell you the weightage of how many times this item set exists in your transaction. Okay. So an item set is considered frequent if we define or if we set or predefine the number of minimum occurrence of specific item set. Okay, so if we have the minimum support is 2, so that means this item set is frequent because they exist at least 2 times. So the minimum support threshold will determine whether an item set is frequent or not, depending on the value that we have here. So if we have the minimum support is 3, so that means this is not frequent item set because they only exist 2 out of 5. Okay, so how do we define the association rules? We are looking at the item set here, and we can have many choices. For example, based on the example that we have here, this is your item set. Okay, so the possibility for you to form a formula here is many. So one of them is this one. So this is one of the rules that you can define based on 3 item set. Of course, you can also do beer, and then it goes to milk, and then diaper. But this, you need to compute the, what we call it, support and also confidence. Okay. So what is the support? So the support just now is the fraction of transaction that contain both X and Y. So if we have the rule something like this, the support is 2 over 5. Okay. And the confidence is basically measuring how often item in Y appear in transaction that contain X. So in this example, your confidence is 2 over 3. Okay. So basically this is your X and this is your X union Y. Okay. So this confidence, the higher is the better, because that means if your confidence is high, that means the rule is very strong, similar to the support that we have here. Okay. So normally we are looking at the support and confidence, but we also have this leaf. This leaf will use the support of A and B divided by support A times support B. So what is leaf? Leaf is a key metric in association rule mining that measure the strength of the association rule. So the higher the value of the leaf, the better it is. So what is leaf? Leaf quantify how much more likely the consequence of an association rules is to occur when the antecedent is present. So we are looking at how strong they will occur whenever you have A here. Okay. So over here, if the leaf is normally, if your support and if your confidence is high and your support is high, so this one will be higher. Of course, this one has nothing to do with this, but this one will also influence how strong is the rules. Okay, so we can look at the support, or we can look at the confident, or we can look at the leaf. Okay, so the task that we can do for the association rules is that given a set of transaction T, so you have T number of transaction, the goal is to extract association rules. Okay, and the rules that we want to extract must have support which is greater than the minimum support. So this is defined by user, and the confidence must be greater than the minimum confidence threshold. So these two are defined by the user. Okay? So when you increase the threshold here, your rules, the number of rules will be reduced. So that means you're only looking at the high support and high confidence rules. Okay, so that's why setting the minimum support and minimum confidence threshold is very critical, because if too high, you will not have any rules that you can use. If you setting the number is too low, you will have so many rules in your bank. So how do we find the rules or the combination of item? So the first thing that we can do is we can try all possible combination of item. Okay, so if we have two item, so basically we have A and B only lah. But if we have three items, so we have A, and then B, and then A, go to B, C, and then C go to B, and so on. So brute force will try to find all possible combination of item to form the association rules. Okay, so setiap ni will have their own support and confidence. So just by counting the item set exists in the transaction. Okay. So for instance, if we are looking at the same, we have milk and a diaper and also beer. Check. Okay. So if you notice that the support is always maintained, because the support is just counting the number of time this three exists in the transaction that we have. Since all of them have the same, so the support is the same here. But the confidence is different. So if you look at the higher is the confidence, the strong they are. So this is one. So that means for the confident, we are looking at every time you have this beer milk, how many times you get the diaper here. So beer and milk and beer, one milk and beer, and then so we have two, and then the other one, so is 2/2. So that's why we have one here. So this is a very strong rules. So normally we will do the ranking based on the confidence, and then after that the support. Okay. So but we as a computer scientist, we are looking at ways on how do we find the rules that we have in our database. Okay, so there are two-step approach that we have here. The first one is we generate all item set whose support is fulfilling the minimum number of support. and then we generate high confidence rules from each frequent item set, because if we have the same item set, your support will be the same, and from there we can do the ranking based on the confidence rules, because the confidence rules formula is different. Okay, so from here we can get the rules that we have. Okay? But the frequent item set generation is still computationally expensive, because we are not talking about 10 or 20 item set. We are looking at million of item set, 10 million of transaction. Okay, for example, like this. Over here, we say that if you have D item in this example, we have 5. Okay, so you have 2 to the power of 5 number of different combination of item set that we have. So this is 1 item set, this is 2 item set, this level, this is 3 item set, and this is 4th, this is 5th item set. So how do you actually looking at this and determine which one is frequent item set? So it depends on the minimum support. Okay, so the complexity of, if one want to find the frequent item set, the complexity is very high here. For example, the N here refer to the number of transaction, and then M here is the number of candidate. So for example, like this is 2 to the power of 2. So this is 2 to the power of 4, and so on. So this is the list of candidates that we have. Okay, and then we also have the number of item here. So basically the number of item set is equal to N times W times the M here. Okay, so this is very expensive, especially when you have large item set, because the large item set will influence your M here. So how do we solve this? So we need to reduce the number of candidates here. Okay, so because the number of candidates here is the complete search would be this one, 2 to the power of D, which is D is number of item set. Okay, so what we can do is we can use pruning technique to reduce the M, or we can reduce the number of transaction, or we can reduce the number of comparison. So we need to deal with data structure, binary tree, and so on. Okay, so if we could also use this principle. We call it a priori principle. Based on this principle, it says that if an item set is frequent, then all of its subset must also be frequent. So for example, if this is frequent, so if you pecahkan them ikut subset, they are also frequent. Okay, so this is the basic property of support measure here. For all X and Y, if there exists where X is a subset to Y, so that means Y have more item than X. So the support of X is always besar daripada Y. Kan? Because the bigger the number you have, you will have reduced support. Okay? So the support of item set never exceed the support of the subset. So this one will never exceed this one. Because if X is a subset of Y, so that means this is smaller number of item set compared to this. So this one has high support. Okay, so this is known as anti-monotone property of the subset. So that means if this is not a frequent item set, automatic this one is also not an item set. Because if this is not frequent, so the value of the support is lower than the minimum support. Of course, this one will also be lower than the minimum support. Okay, so they have this a priori algorithm. For example, like this. If this is not frequent, so which means that the minimum, the support for this one is not greater than the minimum support. Because if you have more here, so all of these are not frequent anymore, because the support here is bigger than the support 3 item set, 4 item set, and 5 item set. So if this is not frequent, automatic, this one also not frequent. Okay, so that is what we call the anti-monotone. Okay, so based on this, we save time in comparing. So we just starting from one here, and then if they are not frequent, then you can leave them out. No need to compare for the next step. Okay, so this is the a priori principle. Okay, so how do we apply this one in the real transaction? Okay, so for instance, over here we have the transaction, and then we say the minimum support is 3. So we start with one item set. So one item set, we list all the possible item set that we have. The possible item with one item set, and then we count the number of transactions. Okay, so since we have the minimum support is 3, so we ignore this. We no longer have to find the next stage here. Okay, so we will couple bread and milk, which is here, and then bread and beer, which is here. So we are looking at all this combination. So based on the single item set, we go to 2 item set. Then we again count the number, how many transactions that exist containing this item set. If they are lower than 3, remove them. Otherwise, we combine them to get the 3 item set here. Okay, so we stop here because this is the only one that considered frequent. So we stop there. So if we are saying that what are the frequent item set that we have for this market basket analysis, so we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 frequent item set. Okay. Okay, we look at another example here. So for example, like this. Okay, the first scan is we list all the. Okay. So the for this one, the minimum support is 2. Minimum support is 2. Okay, 2. So we ignore this one. Then next one, we have this update. So we combine this to form all of this, and then we compute the occurrence of this item set in the transaction. If they are less than 2, we remove them, and then the rest we maintain. Okay, from here we form the 3 item set. We only have this, so this is 2. Then we stop here. No more combination you can do. So this is the a priori algorithm. We start with one item set, and then if they are not frequent, we will leave that one out. No more finding the combination of that item set with the other. Okay, so there are many other methods or the usage of different data structure. Okay, for example, like this, we have the horizontal data layout. We also have the vertical data layout. So from here, we can tell that, okay, for number one exists 3 times, and then number 2 exists 3 times, and so on. So we're just counting this value. Okay. We can also have this frequent pattern tree. So this is very popular because, as you know, that if you have tree, the search algorithm is shorter. The complexity is shorter. Okay. So how do we form this frequent pattern tree? Okay. So we will use the transaction item that we have, and then we will start constructing the tree. Okay. For example, like this. Okay. So we start with the first transaction. So we start from 0, and this is our tree, A and B. And then we have B, C, D. We start with here, but there is no B here, so we have to start here. So B, C, and then D. Okay. Okay, and then we look at A, C, D, E. So we have this one A here. So we update this one. So A now become 2. And then we have C, but there is no C here. We have C here. And then we have D. And then we have E. Okay. Okay. And then we go to ADE. So ADE, so we update this one to become 3. And we have D. And then E. Okay. And then ABC, so we ini lagi A become 4, and then B and so on. So at the end, we will have something like this. So the number here indicate how many times that A exists, but need to be linked to another header pointer. For example, like this, because we will have separate B. We have B here, we have B here, and we have another B here. So we need to have a header pointer. For example, like this, all the B will be connected. All the C will be connected, so that we know how to sum up the number of occurrence for C and D and so on. Okay, so this is the frequent pattern tree construction. How they want to use this one, because the search algorithm is n log n, which is much simpler compared to sequence. Okay, so for example, like this, if we have this tree, so we have A, B, C. Okay, A, B, C is, so when we have the support is 1, so at least 1. So that means we have, this is 1. And also we have AD, we have ACD, we have ABD, okay, and BCD. Okay, so these are all frequent. But if we have 2, let me erase everything. So if, let's suppose the minimum support is greater than equal to 2, so the frequent would be B and ABC, ABC. Okay, and then this is no, this is no, and then this is no. So we only have this as the frequent term. So very easy to navigate through the frequent term, um, frequent pattern tree, because you just go down and then find the connection. Okay. Okay, we also have this vertical data layout. So for example, like this, okay, we have, this is, I think, from the previous slide. So basically, if you want to look at the A and B, so we want to have the number of transactions that are containing A and B. So basically, we are looking at the matching for this transaction ID. Okay, so this is the item A, this is the item B. So if you want to know the number of transactions that are containing A and B, so we just map the ID number that we have here. So this is very fast as well. Okay, so ini contoh-contoh soalan lah. Okay, so given a minimum support threshold of 3, find the frequent item set using the a priori algorithm. Show your work. So basically, we need to start from A, B, from the null, and then we will divide them into 5. This is your A, B, C, D, E. Then we have to look at what are the support for this one. So this is 4, 5, 6, 6. So this is 6 and so on. Okay, so if there are 3 or more, then you can go down to have more combination. Okay, and they want you to compare with the frequent pattern tree. So this must be matching. By using the frequent pattern, you must get the same answer as you use the a priori algorithm. Okay. Okay. So let me walk you through with some of the practical that we can do. So this is what we have done with pharma, where we analyze the market basket for all the transactions that we have in Malaysia. Okay. So given this transaction, the aim is to produce this. So how do we use the R software to produce this one? Okay, so given this is the transaction that we have and we store in the Excel. Okay, let me skip this one. Okay, so for this one, for the data set, we have 9,835 transactions, and we have around 327 transactions per day. Okay, so we have I believe macam 10 days lah. Not 10 days. 30 days, 1 month. Okay, so here we are, I think we are missing this. Missing one step. Let me double check. Okay, we are looking at the grocery. I need to highlight this. So this is the the data that we have. So the content of the data for the first 5 row, we have this. Okay. So we can get the input here. Okay. So what we want to do is we want to create a sparse metric. A sparse metric is it's like a table, but it's similar to this. So for example, we have 5 rows here, but we do not have equal number of columns for each row. So that is the sparse metric. For example, like this, we have 1, 2, 3, we have 4 columns. For the second row, we have 1, 2, 3 columns. And then for the third row, we have 1 column. So this is what we call sparse matrix. We do not have equal number of columns. Okay. So how do we apply the association rules? So we install the package called A rules, so stand for association rules, and then we upload into the memory. Okay, and then we read the transaction from the grocery here. From spelling again, should be grocery. Okay, so I will provide the file later on. Okay, so we read the transaction. So meaning that we tokenize our item. We use the comma here as the separator. And then if we are looking at the summary of the grocery here, we have 9,835 rows, which is the number of transactions, and we have 169 columns. So this is yang paling banyak. So one transaction to they bought 169 items. So remember that we have different number of columns for each row. It depends on the number of items. Okay. And they also mentioned here the most frequent item. So for this one, we have wholemeal. For this wholemeal is 2513. So this is one item set. Okay. So second one is the other vegetables, and then rolls bun, then soda and so on. Okay. But if you increase the set here to become 2 item set, of course your value here will be lower. Okay. So that's why 1 item set will have high support. Okay. So for this one, we are looking at how do we create the sparse tree? So in this example, we have around 2,159 transactions contain only a single item. So di sini we are looking at this one. Okay, and it said while one transaction had 32 items, here. So 32 items, only one transaction here. Okay, so the mean of this matches the value that we calculated manually. So the mean here. So that means for each transaction, we have how many transactions, and we divide the number of item that we have. So that means per transaction we have around 4.4 item. Okay. So we can use inspect to look at the content of your grocery. So this is after we reading, we are looking at the column number, only 5 columns. Okay, 5 columns. So some of them may not have enough 5 columns. For example, this is only 1, this is 2, 3. Okay. But they're looking only 5 columns here. Okay, we can also compute the item frequency. For example, this one we are looking at all the column, all the transaction. So we want to look at the first 3 columns only. And what is the frequency that we have? The frequency is this. Okay, so that means the basic cleaner is the highest frequent item set that we have. Okay, around 0.3% of transaction. We have this abrasive and cleaner. Abrasive cleaner and artificial sweetener are found in about 0.3% of transaction. So we can use the item frequency to compute the frequency of the item that we have. So over here we specify the first 3 column that we have. We can also use the plotting to look at the grocery that has support at least 0.1. Okay, so over here at least 0.1. No, this is the item frequency. The item frequency function. Okay, so this is, we want to visualize the item support. So at least 0.1. So all of these have more than 0.1 support value. Okay, so this is very important because remember just now when we look at the number of comparison. So one of the ways to reduce the number of comparison is by reducing this. So we said we want to have only those who has support equal to or more than 0.1. So we can only select this item to reduce the number of items. Okay, we can also use the top end and specify the number of items that we want to list here. So at least we know that these are the top 20 items that has that are frequent. Okay. Okay, this one we are looking at the image for grocery 1 to 5, row number 1 up to 5. So the dot here refer to here is actually the item that we have. Okay. So this is actually the transaction. Okay. If we look at bigger here, that means this is your transaction. So if you look at here, so this is all the transactions have this item. So we can zoom in what are the items that we have here. If you look at here, this is empty. So that means they are not popular. Okay. So we can use this function called image to look at the pattern for 100 item that we have. No, for the 100 transaction for all the column that we have. Okay. So how do we apply the a priori to find the rules, because we have the data set stored in this grocery already. So how do we apply? So basically we just call the a priori here, we pass the data that we have, and then we can have the list of values, the predefined values, the minimum support, minimum confidence, and then the minimum length of rules that we can add. Okay, so once we have called this, then we have these rules. So how do we look into these rules? So we can see 463 rules, and then if we want to look at the rules, we just mention this. Oh, this is the leaf. Just now. Let me fast forward. Okay, so this one, we have the rules, everything here. So we can list them based on the leaf value. And if you look at here, this is the rules that we have. So this is the top rules having the highest leaf. And it says that if you buy herbs, you also buy root vegetable. If you buy berries, you also buy whipped and sour cream and so on. So this is very important because based on the rules, you can do and what intervention to improve the productivity of certain item or the arrangement of the supermarket in order to boost the sales. Okay. We could also inspect if we are looking at certain item, we can specify them. So we are looking at all the I think we're missing one here. Okay, so over here we are looking at we get all the rules here, and then we only interested on the berries, so we will put them in this berry rules. Okay, so based on these berry rules, we can also inspect what are the rules that we have related to berry. So we can do the sorting, or we can inspect the berry rules that we have. So over here we only do the sorting based on the leaf, top 3 only. So based on this, we can also inspect the rules that we have here. So we have this 3. So this is the rules that we have. Okay. So these findings are very important, not for us, but for the owner of the shop. And it's very interesting also because we did this one for each state in Sabah. So I think I still have that the report. Okay, and we can we can export this one. So we can write the rules here into this file name, and then we use this one as the separator. And we use the double quote to write into the file. Let me show you one paper that we did. Just paling senang. Hmm. Hmm. Okay, so these are the paper that we produce for the study that we have for the whole Malaysia. So just control control output. Or we can also these are the rules that we have, like for each. Can you see this one? Can you see the paper?
Prof, belum share lagi. Belum share screen.
Okay, ya kan? Okay. So these are the paper that we produce based on the study that we have. So we have Putrajaya, we have we have Pulau Pinang and so on. So for each state we study the rules that we have, saying that okay, for whenever you buy ayam, sayur, and telur ayam, then you beli buah. So we have all the leaf, the value of the leaf. So we also have this. This is the illustration of the top 5 Asian rules that we have. So rule number 1 saying that if you rule number 1, where is my ayam? Ayam. I think this one. So for each of the rules, we can even plot this one. Okay, like this one, tarong. If you buy terung, then you buy patin lah. So for these rules, let me zoom. So for this one, rule number 1, so they have 2 input kan, terung panjang and pari. So if you buy these 2, you have the patin here. Okay, so that is the top rule that we have here. So very interesting. This paper is, we managed to produce this paper with the data collection that we have. Without the data, we wouldn't be able to do this one. Okay, so quite interesting. Okay, so any question? I will provide the file. So in case if you want to try, you can have a look. Okay, so for this one, there'll be one question. So that is more into finding the frequent term based on the predefined minimum support. So that's all.
Okay, Prof.
Okay, so I believe you want to study again for tomorrow exam. So all the best.